Assalamualaikum, Haris.
Yes, sir.
Can,
Walaikum.
can you hear me?
Yes, sir.
Okay. Okay, where were we? 13.3, I guess.
Yes, sir.
Did you manage to practice some questions
Sir, I only did
for
one question.
frequency density?
Sir, I did one question of that.
Which one?
Question number, which question I did? Let me.
So I did question 7.
Okay.
Yes, sir. I answered question, sir. So, next question.
What was the demand histogram with boundaries at 0, 20, 30, 40, 60, 80? So frequency density was required
Yes, sir.
because of uneven classes.
Yes,
Let's
sir.
what we have next. We connect this. Okay, scatter diagram. We just discussed something that if it is one is increasing and other is decreasing, we call it
Negative. Negative. Yes.
Yes, sir. Negative.
and then there was weak negative, weak positive, and like this.
Yes.
So strong positive relation and strong negative relation, and in between this is weak positive,
Weak.
and by both increasing, but there is a lot of spread.
Yes, sir.
When correlation is positive, the points around the line and slopes upwards to right. When correlation is negative, the line slopes downwards to right. When correlation is strong, the points are bunched close to a line. When the correlation is weak, the points are more scattered. It is important to realize that often there is no correlation between two set of data. For example, if you take group of students and plot their math test result against their time to run 800 meters. So basically, it does not have any relation between them. One who is strong in math might be slow in the field. So a common mistake in this topic is to see a correlation on scatter diagram where none exist. So there is no correlation in these two scatter diagrams. One may be better in subjects and weak in sports. So line of best fit. We have these marks, mathematics marks and physics, mathematics on X, physics on Y. It is not a compulsion. We can reverse the X's. And we plotted these. Math is 28 and physics is 48. So roughly 28 against 48. So we draw all these points, then we'll draw the line of best fit. It is not necessary that it passes through all of them. Now we have this. So we know that Chikura scored 52 on physics. So 52, and from line of best fit, we can read how much score
34.
she makes.
34.
34.
Yeah.
What is the tip? You cannot make an accurate prediction by extending the line of best fit beyond the range of data collected because you cannot be sure that the same trend will continue. So in some cases, we will extended, that is known as extrapolation,
Yes, sir.
but obviously not too long lines. So here comes the exercise. Plot the points given on a scatter diagram with solar panels on the horizontal axis and pirate sighting on vertical. Use axis values of from 0 to 20. Describe the correlation. Okay, let's try. And let us change this to grid view. Are these lines visible? Blue lines.
Yes, sir.
Uh, I think in white it would be much more clear.
Yes, sir.
Okay. Okay. It says this use axis from 0 to 20 and describe the correlation if there is any between the set of data, for example, the strong, negative, weak, and so on. So I'm going to use 0 to 20, and depending all the values are positive. So considering this as y-axis, this is my x-axis. I'm using 2 for each box. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 2, 4, 6, 8, 10, 12, 14, 20. 18, and this is 20. So solar panels on horizontal axis and pirate sightings on vertical axis. So 7 and 8. This is 7. This is 8. First one done. 16, 15. 16 against 15. 4, 6. 4 against 6. 12 and 12. Then 18, 17. 18. This is 16 and that's 17. Then we have x6, y9. Then x20 and y18. 4, 7, x4, y6, 1, 7. Then 10, 10, and then x13, y14. So when we have to draw a line of best fit, it is not necessary that it passes through. Please accept my freehand diagram. It would be much easier when you draw on paper with pencil and ruler. You will be having
Yes,
that
sir.
flexibility to adjust the scale before drawing the line. So now what is it? Strong negative, weak positive, whatsoever. What is the relationship? What do you think, Haris?
Positive,
Ali?
strong positive,
Strong positive.
strong.
Yes, no problem.
Okay, now these questions will take very long if we like go through all of them and draw
Yes, sir.
all of them. So we are going to skim through questions and see if there is anything different.
Yes, sir.
So just like part A, B, and C are same, we just have to plot them and write the relation. D part says if one of your scatter diagram shows a strong positive correlation, does this mean that you can conclude that the pirates are attracted by solar panels? So yes, because it has a strong positive relation. When solar panels are increased, pirate sightings are
Yes, sir.
also increasing.
Yes, sir.
In question 2, 3, and 4, plot the points given on the scatter diagram with sandwiches sold on horizontal axis, bicycles sold on vertical axis. Draw axis from 0 to 20. If possible, draw the line of best fit on the diagram. Where possible, estimate the number of bicycles stolen on the line of best fit, where the number of sandwiches sold is 10. So if we look at the data, 10 is missing. So basically, for example, if we just draw points and we get this, and then this would be our line of best fit. And when we see that this is 10, so you go at 10, line, draw a vertical line and see what value do you get. Just like this solved example.
Yes, sir.
5. The following data gives the marks of 11 students in a French test and in a German test. French and German. Plot this scatter diagram with French marks on the horizontal axis. Draw the line of best fit. Estimate the German mark of student who got 30 French. That is exactly the same. No difference. Like yeah, maybe this is sandwich and stolen bikes. French and German concept is same. Let me see if I can draw here. I may be able to draw the points, but line of best fit. So 15, 6, and then I have 36, 28, 36, 28. Let's see if it is also showing those points. Yes, it is. Then 36, 35. I'll zoom out once we type in. 36, 35, 22, 18, 23, 28, 27, 28, 27, 28. Then we have 43,
37.
37, thank you. And 22, 9, 43, 41, 40, 45, and last one, 26, and 17. And deleting this raw entry. And these are the points. So we can see the relation is strong positive.
Yes, sir.
Yes.
Hmm. Best fit line.
Yes.
It will be.
There you go. Technology.
Yes, sir.
Sir, but it's only touching 1 or 2 points.
Yeah, because it is not
Uh,
necessary that it should pass through all the line of best fit. Is there. Now, what are the questions? It says plot the data on scatter diagram with French marks done. Draw the line of best fit done. Estimate the German marks of student who got 30 in French. So
So,
French was on x-axis, We see this is 30, and when you go above, this is the third point.
23.
Haris,
Ah,
say that again.
sir, I did it. 25, 26, I think so.
26.
26.
So when x is 30, y is 26.
Yes, sir.
Yes.
So this is it in scatter diagram, and then cumulative frequency. Let me explain a little, then we'll come back to questions. The cumulative frequency, as the word explains itself, cumulates, it adds. For example, we have x and f 0, 1, 2, 3, 4, 5, and I'm writing frequency at random 2, 3, 1, 4, 2, 5. So if I say that x is less than equal to 0, so what would be the cumulative frequency? We are talking about less than and equal to 0. So it is 2.
0, 2. Yes, sir.
Now if I say it is less than and equal to 1, how many do you think there are?
2, 3.
3.
There are 5.
Yes, sir. 5, 2 plus 3.
Oh, okay.
And do you get it? How 5
Yes, sir, I
is
understand.
less than 1 are all of these. And less than equal to 2,
Uh, 1.
6.
6. Less than equal to 3,
Uh,
Uh,
10.
10.
10. Less than equal to 4,
12.
12. And less than equal to 5,
17.
17. So basically cumulative frequency, we keep on adding them. I'm
Yes.
writing
Yes,
this
sir.
again. 2, 3, 1, 4, 2, and 5. So we keep on adding it. We write 2, then 2 plus 3 is 5, 5 plus 1 is 6, 6 plus 4 is 10, 10 plus 2 is 12, 12 plus 5 is 17. So this is cumulative frequency, that was frequency. Now, when we draw graph of cumulative frequency against whatever values are given, this will be cumulative frequency, and on x-axis, suppose a race, and this is a time or marks. So it would look like this, slight more S shaped. Now this highest point will give us the total frequency. As you can see, it is 17, and if you just add all of these, you'll still get 17. So this highest point is going to give us the total number. Lowest point obviously would be 0. And then we have median, we have upper quartile, and we have lower quartile. And it is on x-axis. And they are also labeled as Q1, Q2, Q3. Are you familiar with Q1, 2, 3? Q1 is for lower quartile at
I
20,
not
Yes,
for
sir.
and
Low water and water.
at
Q2.
25%. So this is lower quartile.
Yes.
Yes, sir.
At 75%. So this is
Upper quartile.
on x-axis, whatever the value is this is upper
Upper.
quartile. And
Yes, sir.
then at 50%,
It will be called.
it is median quartile or just median.
Yes, sir.
So interquartile range would be upper quartile minus lower quartile, or you can write Q3 minus Q1. Both are acceptable.
Yes.
Now let's see what the questions have to say. Example question, marks from 1 to 10, 11 to 20, 21 to 30, and so on. Frequencies are given. How many students scored between 1 to 10? 3. How many students scored between 61 to 70 are 14. Then cumulative frequency. So cumulative is less than 10 are 3. And how many are less than 20?
Did 8.
8. 5 plus 3. How many are less than 30?
13.
And so on.
Yes.
So less than 10, less than 20, less than 30 is all of those behind those that number. Now it says the table shows the cumulative frequency plot and cumulative frequency curve and hence estimate. So this is the frequency table and what do we have to estimate? Median. So straight away I can see the highest value is 80. So median is 40. So at 40 we go horizontal and then we read the value from the x-axis. In this case, which is 55. Next is the interquartile range. Interquartile is upper quartile minus lower quartile. Upper is 75. So 75% or 3 by 4 of 80 is actually 60. So at 60, we go and we read the value. Then lower quartile is 20. At 25%, it makes 20 of 80. So we read this value. Then you plug in the both values, lower and upper, and find the interquartile range. Last one says 10th percentile. So 10 out of 100 of 80, this is 8. So we come at 8th level and read the value. Question number 1. Figure 1 shows the cumulative frequency curve for the marks of 60 students in an examination. From the graph, estimate the median mark.
30. No, no. Wait, 30. 46.
46 something, yes. So median is around 50% mark. And we go to this
Uh,
and we read whatever is there.
yes.
Yes, 46 or 47. Let's say 46.
48.
48 maybe. It would be very clear in exam. Like we will be able to
Yes.
count those small boxes.
Yes.
Grid is centimeter by centimeter.
Yes.
Second says the mark at the lower quartile and the upper quartile.
Lower quartile is 30, I think so, because it will be 15. And
And
Against 50.
upper quartile will
so
be 5.
45.
And it will be
It will be
So this is lower quartile
60 mark.
and up to
yes,
45.
61.
60.
Okay. So mark at lower quartile and upper quartile. So this is 30 and that is 60. And
60
interquartile
minus 30.
Yes,
upper
30.
minus 30.
30.
Oh, very good. D part, the pass marks if two-thirds of the students passed. Now two-thirds are passing. Two-thirds of 60 students passed means 40 students passed.
40
40,
students.
yes, 40.
Now
Yes, sir.
what is the value? How many marks are the passing marks?
Sir, 40.
40.
60.
Yes.
60 marks passing.
No,
No.
sir. So 20.
Let's
36.
Okay. Ali says 36. Aris, what do you think?
uh, just wait. It's 40, right? 21.
21.
Just wait, I think I did something.
Let me clear this.
Wait, wait, it's
Now
40.
this says that 2 by 3rd are passing. That is pretty much obvious.
Oh, yes, okay. Okay.
40 students are passing. They must
Yes,
be
sir.
these 40.
Yes, 40. It
Yes,
will
sir.
be 40, 55.
Haris, not this 40.
Oh,
Upper 40 students are passing and lower 20 are failing. So 40
Yes, sir.
students, and this should be 36 marks
36.
and above. They are passing.
Yes, sir.
Okay.
E part says the number of students achieving fewer than 40 marks. This is in the reverse direction. Fewer than 40 marks are on x-axis. If I see here,
20,
and
22,
23.
22.
okay, 23, 22. So less than 40 marks are 22 students. 10th percentile. So 10 out of 100 of 60,
0.5.
they are 6
So,
students. So 10th percentile, we go at 6 and we read this value.
will be, sir, won't it be 10?
So ready to do the working.
Ali
No.
10th percentile of
Yes,
the
sir.
total.
Yes, sir. Yes, sir.
So total was 60
Yes, yes, sir.
and 10th percentile of 60 is 6.
Yes, sir.
10.
10 out of 100 of 60 is 6. So that is why we went at 6 and we read this value.
Okay.
11.
Now 90th percentile. So
90th, sir.
90 by 100
54
into 60,
50.
Q 54. So we go at 54
or 80.
and we read that value 80.
Yes, sir.
Now cumulative frequency would be simple. We'll have these type of tables. Marks, this is basically X. X will be given, frequency will be given. Most of the cases, cumulative frequency is given, and if not, we know how to find that. 3, then 3 plus 5, then 3 plus 5 plus 5. We add all these 3, then we add all these 4, and so on. We keep on writing. So, and we draw cumulative frequency on x-axis and all the classes on cumulative frequency on y-axis and all the classes on x-axis. So this is cumulative frequency, and that is x, whatever it is in the data. And then these are the parts, A, B, C, D parts, which may be different. Other than that, cumulative curve is same. Figure 2. Figure 2 shows the cumulative frequency curve of marks of 140 students in an examination. From the graph, estimate the median mark, the mark at the lower quartile, and at the upper quartile, and the interquartile range. Okay. So one by one, median quartile. 140 by 2 is 70. So at 70, we read this median quartile,
Uh, 31 or something. Yeah.
and then the mark at the lower quartile
It
and
will
upper
be
quartile.
11.
140 into 1 by 4
Yes, sir.
is for lower quartile, so 35. 20, 30, 40, 35 is somewhere here.
So we can also like divide 70 by 2.
Yes, we can do that.
What I look at that.
And for upper quartile is 140 into 3
3
by
by
4.
4.
So which is 35 into 3, 105. So this is 110 and 105 is somewhere here.
Yes, sir.
And they get 42 or something. Interquartile range is upper quartile,
42 minus 26.
lower quartile. When was our exam? 22, 26 something.
Yes, sir, not 26.
And when is the first exam?
16.
16.
16. So today is 8. Our one chapter is left. Hopefully We'll be able to do it in the next class. And before exam, we can do past paper practice. Okay, same question, D part. The pass marks if 3/5 of students passed. So 3 by 5 of students are passing, and 3/5 of 140 gives me 84. So when 84 students are passing, they are the ones at the top. So we mark this at 56. And passing marks are 30 marks. Is this thing clear? Why we did 3 by 5 of 140, then why we subtracted it from 140?
Yes, sir.
Yes, sir.
If this question would have been for a race, then we will select the number at the lower end because lesser time would mean a better player. Right.
Yes, sir.
So it would depend on the nature of question as well. E part says the number of students achieving more than 30 marks. So it is straight away, we just read at 30 and more than 30. Let's say I'm getting this 56. So more than 30 is 180 minus 56. F part says 15th percentile. So clearly 15th by 100 of 140. It gives me 21. So 21 on the y-axis. And we read the answer on x-axis. Suppose 21 marks. For question 3 to 6, draw the cumulative frequency curve and estimate the median. So cumulative frequency, first one is 4. Then we have 4 plus 7 is 11. Then we add the next one plus 11 is 22. Then you add the next one plus 18 plus 22 plus 10, then plus 5, then plus 3. So we get the cumulative frequency values. And what will we do? We'll draw from 0 to 80. And we have these classes 5, 10, 15, 20, 25. Now don't forget that we are drawing these. We will draw 4 at this 5 mark. Then we will draw this 7 at 10 mark and so on. So 5, 10, 15. Don't forget that when we calculate mean, we use the middle values. And when we are drawing cumulative frequency, we use the higher value. Here,
Yes, sir.
question number 7. In an experiment, 50 people were asked to guess the mass of bunch of flowers in grams. The guesses were as follows. Construct a frequency table in interval this, draw a cumulative frequency. So it's just increased the workload of this question. And we'll first draw that 0 to 9, 10 to 19, 20 to 29. Let's say from 0 to 9. So basically they would be etc. And 30, 39, 40 to 49, 50 to 59, and 60 to 69. We'll see if we need more values. So from 0 to 9, I can see only one single digit and tally. Then 10 to 19. I'm moving from vertically. This is one, two, three, four. One, two, three, four. Then we'll write frequency. 20 to 29. One, two, three, four, five, six, seven, eight, nine, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 1, 4, and 10. Then 30 to 39. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then 40 to 49. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 12. 50 to 59. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 60, 69. 1, 2, 3. 1, 2, 3. Now cumulative frequency. 1, 5, 15, 28, 40, 47, and 50. Cumulative frequency, I'm writing it separate. 1, 5, 15, 28, 40, 47, and 50. And when we will draw this, we'll have 0 to 9, then 10 to 19, 29, 39, 49, 59, 69, so on. And now we'll draw this. Against 9 is 1. Then against 19 is 5. Against 29 is 15, 28, 40, 47, 50. And this would be our cumulative frequency curve.
Yes, sir.
I'm leaving this question and I'm coming on next exercise. Do try this one question.
Okay.
Please note the page number so it's easy for you to find.
Yes, sir.
This is page 445, question 8.
Yes, sir.
Yes, sir.
The comparing data set. As it is self-explanatory, we'll have some data or some sort of graphs and we are going to make the comparison. Exercise 13.6a. After finishing dinner, Zach and Lucy had 4 hours before going to bed. The pie chart shows how they spend their time. So Zach's evening, he spends most of the time online. Lucy spends most of the time in homework. Zach spends least time in homework, whereas Lucy spends least time in online. And then household chores and reading and so on. So whatever the nature of the question would be, we can also change it into percentage and
Yes, sir.
we can convert it. Who spent more time reading, Zach or Lucy?
Lucy.
Lucy, right?
Lucy.
How many minutes did Zach spend doing his homework?
Uh, what the-
So it will be, where is it?
Okay, let's
30 over 360 times 4. So 30 over 360 times 4
that's right. This is in hours. So 30 over 360 times 4.
times
And if
4.
I just multiply it with 60, it will give me answer in minutes.
Yes, sir.
Getting
20 minutes.
20 minutes.
good, Aris. Okay. And how many more minutes did Zach spend doing household chores than Lucy?
So we
So
will find out how much Zach did. It will be 135 for 360 times 4 times 60
This is 90.
and
very good.
102 over 360 times 4 times 60.
90 minutes, and on the other side is
22 minutes more.
in Q 102 by 360,
Yes, sir.
4
Minus
times
4 times 60.
So we'll do 90 minus 68.
68,
And then 90 minus 68.
22 minutes more. So simple comparing data. Now, if we just don't go through the question and I see children and adults, on x-axis I can see number of olives, on y-axis is the cumulative frequency. So I can see that adults are consuming more olives. Do you agree?
Uh, yes, sir.
Because if we just draw horizontal line at 30, children's are consuming this much and adults are consuming this much. So right hand shift means more. A group of 60 children and group of 60 adults were asked to guess how many olives there were in the jar. Okay, that was a guess. I thought they were eating it. Jar. Their responses have been illustrated in the following cumulative frequency graph. Work out the estimate of median and interquartile range for both the groups. So let's start with children. Median out of 60, it is at 30. And I'm reading, let's do it for both children, adults, median. So when we read this is roughly 62 and that's roughly
71.
let's
71.
71. And interquartile range we need upper and lower quartiles. So at 45, 75% of 60 is 45. The children at 45 are a bit below 78. Upper quartile 78.
And lower quartile, I mean upper quartile for this one is 82,
80. Okay.
81.
Okay, let's make it 82. And then lower quartile. Lower quartile 1 by 4 of 60 is
15.
so at 15.
15, 50, and 6,
I
50.
think it's a little bit before 50.
Yes, 15, 49, I think so.
So 49. And on the other hand,
Mm,
Uh,
55, 50,
57,
58 maybe.
56,
This is 55 and 56.
58.
58 maybe. Okay,
Okay,
50.
let's make it 57.
Okay.
56, 58 in between 57. Interquartile range is upper
Uh,
quartile minus
Minus lower chord.
Lower
lower quartile.
quartile.
78 minus 44.
78 minus 49 is 29. And 82 minus 57 is
25.
25.
Yes, sir.
B part says given that there were actually 70 olives in the jar, which group was better at guessing? So if there were 7,
Okay.
see this median. Adults were close to that.
Yes, sir, it is.
It was later discovered that the group of adults who were asked all enjoyed Italian cookery. What might you infer from the results? I can
Mm,
infer nothing out of this because they are not relatable.
Yes, because it's
yes,
not
sir.
mentioned here.
Crockery and olives are two different things.
Yes,
Yes.
sir.
And then revision. Please do not waste your weekend.
Yes, sir.
Comparative
Yes,
Okay.
sir.
fluency statistics is easy, but you have to